Welcome to the
Deep within
digestive
your
system.
lower
We are
abdomen
now
lies a
traveling through the
small,
large intestine,
finger-shaped
also known as the
pouch.
colon, towards the cecum. Finally, we arrive at the appendix.
It is called the appendix. For generations, it was considered a useless organ. After all, people can live normally without it. But being non-essential does not mean being meaningless. Is it merely a remnant from our ancestors? Or has it been quietly supporting us all along? If it is useful, why can it become dangerously inflamed? The answer connects evolution, immunity, and the bacteria living inside us. This tiny pouch may be far more interesting than it appears. First, let us find exactly where this hidden organ sits. Your digestive tract is a winding biological highway. Food passes through your stomach and small intestine. It eventually reaches the beginning of your large intestine. This first section of the large intestine is called the cecum.
We begin with a
The appendix
three-quarter
hangs
view of
from
the
it like a
cecum and the
narrow
normal
pocket.
appendix. Note the subtle swaying motion indicating natural intestinal movement.
Small but noticeable. Yet its exact position can vary, surprisingly, between different people. You normally cannot feel it doing anything inside your abdomen. On most ordinary days, you completely forget that it exists. That daily silence helped create the appendix's unfortunate reputation. Early anatomists could see the appendix clearly during careful dissections. Yet its true purpose remained frustratingly mysterious for centuries. It did not appear to digest any part of a meal. It produced no obvious juice, hormone, or other substance. Removing it caused no immediate or obvious biological disaster. The verdict: useless evolutionary leftover. That simple idea became extremely popular among doctors and scientists. Even Charles Darwin considered the appendix while exploring human evolutionary history. Our plant-eating ancestors needed help processing tough vegetation. They likely possessed larger fermentation chambers in their intestines. Microbes inside those chambers helped break down plant material. As our ancestors' diets changed, those structures became smaller. The appendix was linked to this shrinking system. Convincing enough. But evolution rarely leaves behind such neat and simple stories. Scientists later compared appendixes across many mammal species. They found similar structures in surprisingly different animals. Some distant mammal lineages apparently developed an appendix independently. Other species kept similar structures across millions of years. This surprising pattern raised an obvious question for researchers. Why would nature preserve something that offered absolutely no advantage? Evolution does not deliberately design perfect bodies from scratch. Instead, it gradually modifies biological structures that already exist. Seriously harmful features often become less common across many generations. Truly neutral features may simply remain because they cause little harm. Meanwhile, useful features are more likely to be preserved. So the appendix could be reduced, yet still functional. The first major clue lies hidden within the appendix's walls. Those walls contain abundant tissue connected with immune defense. Think of it as a tiny immune surveillance station. It helps immune cells monitor substances entering the intestine. During childhood, this activity may be especially relevant. The gut constantly meets unfamiliar food and microorganisms. Most of the microbes it encounters are completely harmless. Some help us. However, a smaller group may sometimes cause serious disease. Your immune system must somehow learn to recognize the difference. The appendix may help support part of that early training. However, this tiny organ certainly does not work alone. Similar immune tissue exists throughout other parts of your digestive tract. The appendix remains only one small participant in a larger network. That explains an important paradox. It can contribute without being essential. Removing it does not erase intestinal immunity. The remaining system continues its work. Then researchers noticed another intriguing possibility. The appendix contains communities of gut bacteria. These organisms form part of your microbiome. Usually they live throughout the colon. But intestinal infections can cause severe diarrhea. Large numbers of microbes may be flushed away. Imagine a flood sweeping through a crowded city. Afterward, the community must rebuild. The appendix may offer a protected side street. Its narrow location could shelter beneficial bacteria. Those survivors might later repopulate the colon. Scientists call this the safe house hypothesis. A compelling idea. Evidence supports parts of it. Yet the full story remains under investigation. The appendix is not a magical bacterial backup drive. Modern sanitation also changes the situation. Clean water and medical care reduce many intestinal infections. Our ancestors faced them more frequently. A microbial refuge may have offered greater advantages then. Today, its benefits can seem almost invisible. Unfortunately, its risks remain very visible. Sometimes the appendix becomes inflamed. This condition is called appendicitis. It often begins when the narrow opening becomes blocked.
Fluid accumulates behind the blockage. The internal pressure rises.
Hardened stool can sometimes create that blockage. Swollen tissue may also close the opening. Pressure then builds inside the trapped pouch. Bacteria multiply while inflammation worsens. The appendix swells and irritates surrounding tissue. Pain commonly begins near the belly button. Later, it may move toward the lower right abdomen.
Lower right. It hurts.
The pain usually becomes stronger. Movement can make it worse. Coughing may hurt to many people lose their appetite. Nausea, vomiting, or fever may follow. But symptoms vary widely. Children may describe the pain poorly. Older adults can show subtler warning signs. Pregnancy may shift the appendix upward. Possible appendicitis, therefore, requires urgent medical evaluation. Doctors examine the abdomen and review symptoms. Blood and urine tests provide clues. Ultrasound or scans can confirm inflammation. Quick diagnosis matters because swelling can progress. The appendix wall may lose its blood supply. It may rupture. Then infected material may enter the abdominal cavity. This can cause peritonitis or an abscess. Both require urgent medical treatment. That sounds frightening. Fortunately, modern treatment is usually effective. Surgery remains the standard approach for many patients. The procedure is called an appendectomy. Surgeons often use several tiny incisions. A small camera guides their instruments. Recovery is usually faster than after open surgery. Antibiotics help control bacterial infection. Some uncomplicated cases may receive antibiotics without immediate surgery. That decision requires careful medical evaluation. Treatment depends on each patient's condition. A ruptured appendix needs more complex care. After removal, digestion continues normally. People eat, work, and exercise as before. Their immune systems continue functioning. Their microbiomes also find new balances. This does not prove the appendix was useless. Your body contains many overlapping systems. One part can compensate for another. You can live with one kidney. That does not make kidneys pointless. The same logic helps explain the appendix. It offers support rather than survival. Its contribution may depend on circumstances. In a healthy modern intestine, that contribution seems small. During infection, it might become more valuable. Researchers are still testing these possibilities. Future discoveries may revise the picture again. Science often works that way. A useless organ becomes a biological mystery. The mystery becomes a story about cooperation. Immune cells, bacteria, and evolution all share the stage. So why do we have an appendix? It is partly an inheritance from our evolutionary past. It may also support immunity and beneficial gut microbes. We can survive without it, but that misses the point. Sometimes, evolution's smallest leftovers still have a job.